This is a video on selecting the scale of a graph in physics. We're going to give you two examples here. The first example is using the focal length of a concave mirror experiment. There's a set of data with 4 pairs of values. Not ideal for plotting a graph, but I'm going to do it nonetheless. Really, you should have 6 or 7 pairs of values to plot a graph. And what I always suggest is to change those into columns. So U is the object distance, that should be in SI units. So instead of 12 centimeters, we have 0.12 centimeters. V is the image distance, that should also be in meters. So instead of 64.5 or 22.1, I'm getting 0.645 and 0.221 meters. And what we want is a 1 over U and a 1 over V in each case. The reason for that is because the formula has a 1 over U and 1 over V in it. So our graph work should reflect the formula that pertains to the particular experiment. So I'm going to get 1 over each of those U values. So 1 over 0.2 is roughly 8.3. 1 over 0.18 is 5.6. 1 over 0.236 is 4.2. And 1 over 0.3 is 3.3. I'm going to do the same then for the V values, get 1 over all of those. And then the thing in the red box is the thing that I'm going to plot. So we're at the main focus of this video, and it is how to identify what scale to use in a graph. Well, it's very straightforward. You take the biggest number from each column, and that tells you the number you have to go up to at least. So if we look at the 1 over U column, that's going to go on the x-axis, so the horizontal one. The biggest number there is 8.3. So if I went up to 9 in even jumps, then the 9 value would allow me to have all of those values displayed on the graph. If I took a look at the 1 over V column, the biggest number there is 6.5. So if I went up to, let's say, 7, all of those values would be contained within it. All right, so what do? We pick the largest value from each column. That gives me my biggest value on the axis scale. And then we need to go from 0 to at least that value. And again, in the 1 over U column, the biggest value is 8.3. So I want to go from 0 to at least 8.3 in even jumps. As we can see from the video, I'm going to go from 0 to 9 in even jumps. That means each of those increments or jumps are of 1 unit length. If we look at the 1 over V column, biggest number is 6.5, so I want to go from 0 up to at least 6.5. I'm going to go up in just ones again, so I'm going to go from 0 to 7, and then all of my Y values can be contained within that range of values. Once you have that, then you just plot your groupings of points. So the first one to go down there is the 3.3 and 6.5. The second one, 4.2, 5.6, 5.6, 4.5, and then 8.3 and 1.6. So the 1 over U and 1 over V are the X and Y respectively. Draw a line through them, and I'm not going to finish off the experiment or the work on the graph in relation to this. Second example. So displacement time, we're going to plot a displacement time graph according to this value. There's nothing to do to this set of data because the formula is velocity is displacement over time, or just distance over time. So we have our table, we have our graph. What's the scale? So on the x-axis, the horizontal one, the biggest number is 6. So I'm going to go from 0 up to at least 6. And I think every second increment could be 1. So every small increment is a half. And then on the y-axis, I need to go up to at least 19. So always start at 0 up to 19. And let's say I'll go up to 20 in this case. So 0 to 20. There we go. I've decided that each of those jumps is going to be a distance of 2 on that scale. And then we just plot the points that are given in the table. So we have 0, 4, 2, 9, 4, 16, 6, 19, and plot your line through it. So the thing to take from this is when you're trying to get the scale on your axis, so the scale on the axis always starts at 0 in the bottom left hand corner, and then it goes horizontally across in even jumps up to the biggest number that you're given in your table, and then on the y-axis goes from 0 up to at least the biggest number in your table also.